Okay, so let's look at the double angle and half angle formulas. So let's start with the double angle for cosine, starting from the sum formula. Versus sum formula is cosine alpha, cosine beta, minus sine alpha, sine beta. And so if we do cosine of alpha plus alpha, that makes cosine 2 alpha. This is the double angle formula. So I've got cosine alpha minus sine alpha, and that makes cosine squared alpha minus sine squared alpha. Sometimes you'll see this substituted in terms of, we know that sine squared plus cosine squared equals 1. This is the Pythagorean theorem. So for instance, sine squared alpha would be 1 minus cosine squared alpha. And so I can put this in. Of course, careful with your distribution of the subtraction because that cosine squared is not disappearing. We're going to have 2 cosine squared alpha minus 1. And while we're here, I suppose it's worth saying this is the origin of the double angle formula, the half angle formula, because if cosine 2 alpha equals 2 cosine squared alpha minus 1, then we can say that, rearrange this for cosine alpha, cosine 2 alpha plus 1 equals 2 cosine squared alpha. Dividing it by 2 gives us cosine squared alpha equals cosine 2 alpha plus 1 over 2. And now I take the square root. So cosine alpha equals the square root plus or minus cosine 2 alpha plus 1 over 2. We're not sure which one it'll be. It depends on the relationship between this angle and this angle. So the reason this is called the half angle formula is because if I rename 2 alpha as theta, then alpha equals theta over 2. So in other words, cosine of theta over 2 is equal to plus or minus cosine theta plus 1 over 2. So that's cosine's double angle, cosine's half angle. Let's do sine's half angle. Well, I'll just say you can do that for yourself, but you would start here. Well, I'll give you a second to look at what you've got and think about what you would do. Pause and think about it. So start here, but instead of substituting for sine squared alpha, substitute for cosine squared alpha, then you end up with an expression that has only sine squared in it. And you can then rearrange that in the same way we did here for sine alpha, make this substitution, and you get yourself the half angle formula for sine. So that's cool. Let's do one more. We're going to do double angle for sine, starting again from the sum. And so the sine is sine alpha cosine beta plus cosine alpha sine beta. And then we are just going to do the double angle. So alpha plus alpha, that's sine 2 alpha. So then we get sine alpha cosine alpha plus cosine alpha sine alpha. But of course, if I have xy plus yx, then it really doesn't matter what the order of the multiplication is. So I just have 2 of those things. And that's what happens here. 2 sine theta, cosine alpha, sine alpha. So that's the double angle for sine. Okay. So we can go a step further and look at, say, tan 2 theta, which of course is the double angle for sine divided by the double angle for cosine. And so if we substitute here 2 sine theta cosine theta divided by cosine squared theta minus sine squared theta. We get kind of the general form. Now, where we're headed is we're going to be looking at proofs. So let's just set ourselves a little challenge here. So I'm going to clear this out. I guess I'll erase the top part. So we want to prove that tan 2 theta is equal to 2 over cotangent theta minus tangent theta. And in a proof, we're going to work down. This is really what we're going to hit hard in this next section. We want to go from here down to here. So we're not doing things to both sides. We're not treating it like an equation. And I've already demonstrated that we can get from tan 2 theta to 2 sine theta cosine theta over cosine squared theta minus sine squared theta. So this is where we are. And now I'm going to move this part here down to the bottom to be my target. 2 cotangent theta minus tan theta. All right, I'm going to erase this. This is kind of how I think about a proof. Now, remember with the proof, and really in any problem that you're trying to solve, you can work forwards or you can work backwards. Proofs are actually a great opportunity to practice that. So here, 2 over cosine theta sine theta minus sine theta over cosine theta. So I'm kind of feeling this here. What if I got a common denominator? So what if this was 2 over cosine squared theta cosine theta sine theta minus sine squared theta over sine theta cosine theta. Yeah, and I think we're there basically, because at this point you can see that if I divide the top and the bottom by sine theta cosine theta, that'll leave me with 2 on the top. It'll give me these 2 fractions on the bottom, which then can simplify down to cosine over sine and sine over cosine, and then you get 2 over cotangent theta minus tan theta. So there's a little freebie proof for you. This is where we're headed into the next section, and a great example of working backwards to help bridge the gap between here, which seemed like a reasonable place to be, and here, which ended up looking a little bit simpler. Okay, we're going to do one more video in this section, and then we're going to move on to 3, I think.